Good morning. This is Nate Shotwell, and I would like to share with you a lab that I do during the school year with my eighth grade physical science kids. Some of them are collabs, some of them are regular. I've also done this with seventh grade. We're going to look at this lab as a case study for different strategies that you can use to incorporate inquiry into your own classroom, and particularly to differentiate inquiry within the same classroom where not all the kids might be at the same level and ready for a full inquiry experience. So I start this lab off as kind of a 5E lesson. I give them an engage opportunity. We get out the ice melting blocks, which are kind of fun. They look very, very similar. One of them is made out of aluminum. The one on the left is aluminum. The one on the right is a black foam material. The aluminum one feels kind of cold to the touch. The kids all experience that when we start. And the foam one, room temperature, kind of feels average. And so they kind of experience that. And then we get the ice out. We put the ice on these ice melting blocks, and madness ensues because the one on the left felt cold, but it's the one that's melting the ice. So we can kind of all guess what's happening with the heat. Same as the heat very quickly left our finger into the aluminum block because it's a conductor. Here, the heat is very quickly leaving the aluminum and going into the ice to melt the ice. And so that's kind of the way that I kick this lesson off. Get a bunch of those ice blocks out, put them all over the desks, get kids engaged very early on with what we're going to be studying, which is conduction, convection, and radiation. From there, I get out a lot of different materials. This is just kind of some of the stuff that we get out for this lab. This is a conductometer up here on the left. It's something that I think all the middle schools got last year. Really good for testing the conductivity of different metals. Infrared thermometers are always fun. We do talk a little bit about safety as I'm kind of explaining this stuff, that this guy could get pretty hot. This is a little red light, a little laser, so don't point it at anybody and certainly nobody's face, eyes, etc. We use little alcohol burners for this lab to heat things up. The candles don't work so great on this. It takes forever to get the heat to melt. So you can use a larger burner to get them to melt a little bit faster. And all sorts of other stuff. Ice, different kinds of light bulbs. These radiometers are always fun. The black side, I guess, heats up and then pushes, and the white side reflects. And so they spin as you shine different lights on them. Colored paper, just a lot of different stuff. And I kind of explain how it all works, explain how the remote control might work on that LED light bulb so you can change and use different colors of light. And at this point, we're ready for an open inquiry investigation. So by open inquiry, I'm not going to be giving the kids the question that I want them to investigate. I'm giving them a lot of different materials. They can kind of see how they work. I've given them a rundown on that. And then it's time to ask questions. At this point, I'm going to direct your attention back to our Schoology page for this course. I use the inquiry lab template that's here with a lot of my inquiry investigations. And so I'm going to kind of use that as a guide to walk you through what this investigation looks like. So if you found this video, that lab template is right above this. And I'm going to kind of take it apart and go piece by piece through it and share some ideas with you for what you could do at different steps along the way to support your students. The first step on the inquiry lab template is posing a question or asking questions. And so with all that stuff that we saw in the previous slide, there's so much that kids could decide they want to investigate. I'm not going to read through all those, but those are some of the ones that I've come up with and some of the ones that the kids have come up with. And the nice thing about it is if you've got different kids learning different things during the lab than after the lab, that explain portion of a 5E lesson becomes so interesting because not everybody did the same thing and they're able to listen and learn from each other. And so they, investigated conduction with a conductometer or with ice melting. They're going to have different results in a fundamentally different experiment than if they were using the radiometer to investigate different light bulbs and how much heat they put off or how quickly they made it spin. And so there's a lot of different conclusions that we can draw from the lab. And really, again, the reason we're doing this is because I want to talk specifically about what you can do to support your students all in the same classroom, maybe experimenting even at different levels of inquiry. And so with that questioning step, that's one of the hardest ones to incorporate into a science classroom safely. You got to pick the right topic in order to do it. Once you pick that right topic, how do you get kids to ask questions? Well, with this one, I started off with that black cubes melting ice. And that's a really great way to kind of get kids interested and engaged right at the beginning. So I encourage you to consider doing that at the beginning of a lab. Like I walked you through just a moment ago, any equipment or materials that they're going to be using, you want to kind of make sure that they understand how to use them and what they might be able to find out by using them. If you're using a probe, what does the probe measure? How does it work? If you're using a piece of equipment like that conductometer, what is it that you would do? I don't take data, but I illustrate to them when I start, hey, I can put this over the fire, and there's little wax dots at the end of each one of these, and the wax will end up melting once they get hot. And so then they can kind of in their brain start to see the questions that they might be able to ask. You could use different brainstorming techniques to come up with questions with the kids, whether you're doing it all together as a class or using a strategy like Think, Pair, Share. Lastly, one of the things that I've had a lot of success with is having kids kind of come up with one or two questions that they're really intrigued by and circling that on a lab sheet, maybe doing this the day before we start with the lab, and then trying to come up with some groups based on what they're interested in. And that way you don't end up with a scenario where there's 3 children in a group, one of which wants to investigate with the conductometer and 2 of which want to use the radiometer, and they just can't come to terms. If you know that they're all interested in the same thing, that's going to give that group some momentum on lab day. The next segment of that inquiry lab template deals with kind of designing the experiment. And so I use a pretty standard experimental design where they're going to come up with the independent variables and the dependent variables, come up with their own hypothesis. You can use your own, but this is the one that I like. The one that the kids do always have trouble with is figuring out where the control is. And I do find that by using this same template repeatedly throughout the year, they do get better with that. It's something that after they've done this a couple of times and used that same template, there's usually somebody in the group by the second or third inquiry investigation that says, oh, the control's the normal one. That's the one that we need to be able to compare back to. So they're going to set this guy up. They're going to set up their procedures. I get the idea from Ms. Hill over at Fairfield a couple of years ago to incorporate safety into this. I thought that was such a great idea to make sure that they look at that procedure and then write down any safety considerations that they need to use. One note for you is that inquiry investigation template, which is available in our Schoology class course, it also has rubrics kind of embedded throughout, and that really provides an outstanding opportunity for dialogue with the kids. I'm going around, I'm working with them, I'm looking at what they're doing. I'll give them kind of a moving target of here's where you are right now. What can we do to move this forward? And that really helps to kind of get the kids recognizing that with anything in class, it's not about the grade, it's about trying to grow and trying to get better. And so I really like having that rubric there. And I do find that when I provide them feedback and they're getting something less than the top mark on the rubric, that encourages them to go back and think about what they've done and think about how they can improve it. And I love that when that happens, even during an activity. Some things that you can do during that planning phase to develop your kids' skills and abilities using inquiry in your class. One of the things that you can do, and I don't have it here, but back in that same Schoology group, there's an interest survey, and that kind of lets kids know and lets you know what level of structure children like, and are they going to succeed or are they going to flounder if you throw them to the wind and let them come up with their own solutions. So that inquiry interest survey, that's not something I've used before, but I did find it in researching for this course, and I love it. I think that it's something that I'm definitely going to use going forward this year. One of the other strategies that I do like to use is use any sort of pre-assessment you want to figure out where your kids are, both in terms of content and in terms of their lab ability as you are preparing for lab. And then it's up to you to decide whether you're going to group them heterogeneously, so you've got strong students in every group that can serve as a leader, or maybe you're going to group them homogeneously and know that you're going to spend more time with the 2 or 3 lab groups that will need additional support. And I've used both of those strategies. I like them both. I really like that homogeneous one because I'm able to spend more time with the kids who need more support. I'm able to let the students who are kind of ready to fly, I can let them go and support them as needed as well. So it's up to you what you're going to do in your classroom. You could do a mix and match there. One of the other things that I find works really well is when it comes time to start reviewing procedures, I do need to look at all of them before they get started, but it always seems that they're all ready to have me look at them at the exact same time. If that happens to you, you can use a peer feedback mechanism where you're going to kind of trade and provide some feedback, and that will, I don't want to say buy you some time, but it also encourages kids to look at other procedures and see what other groups are doing well and what they might be able to improve upon. And it also will allow you to get around and support your kids a little bit better. And the last thing that sometimes you have to do, depending on the kids you're working with, the class that you've got, you might end up having some procedures ready. And one of the things that we try to do with the framework, and it's not done with all courses or all labs, but we're working towards providing a variety of different levels of labs so that you might be able to have different students in the same class doing the same lab but receiving a different level of support. And you might end up handing a procedure to one group that is, they're going to struggle with that. You want them to have the rich experience of collecting their own data and analyzing it. You don't want them to get bogged down in the procedure. And so it might just be that after 10 or 15 minutes, 20 minutes of procedure writing and review, you're handing a procedure to a group. Or maybe that happens even earlier based on you and your classroom and your students' needs. So you can kind of think about that as a strategy, that not all kids need to have the same lab experience to be able to have a rich lab experience. And then it comes time for the data analysis. And I'm really trying to kind of mirror this after those levels of inquiry that the first video that we talked about with the chemistry teacher. Who's coming up with the question, who's coming up with the procedure, and then who's coming up with the results. And so as we come to this kind of last phase, as you're constructing a data table and constructing a graph and making meaning out of it. And this is kind of where typically at the end of a lab, I will have some additional questions that are very specific to that lab that I will add on as analysis or conclusion. But the data table and the graph is something that I just kind of leave this open on all of my labs. And sometimes kids do labs and you just kind of look at it and say, I don't know what we're going to do for a graph here, and that's okay. But oftentimes this works really well. And so what I have done, and then really what I would like to do over the course of the past couple of years, and my goal for this year, looking at how to support students as they get into that analysis phase. Obviously, Anchor Charts is super successful in terms of having kids have something that they can go to and look at. I want to take that one step further this year and trying to put together some tutorial videos in Schoology so that if they're having trouble with the data table, they're having trouble with the experimental design, if they're having trouble figuring out how to set up their graph, I'll have some real short videos that they can go access in Schoology that they're kind of there all the time, anytime, so that whatever lab they're on, if they're struggling, they're able to go and kind of tap into those. And so that's kind of my goal for this year, that's taking this a step further. And then the last piece there, obviously sometimes you've got groups that they just need that extra support. Sometimes I've got a data table ready to go that I'm just ready to hand to a group. Hey, you're really struggling here. I understand the video didn't help. Sitting down and working with you, we're not making it through it. And so you have kind of a blank data table that you can hand them and not expect them to create it. And so there's so many different ways to support students. I hope that these strategies have given you some insight and some ideas about how you might be able to offer some differentiated options within your classroom so that your kids can have successful inquiry experiences, maybe even at different levels at the same time. Thank you so much. And if you do have any questions, I'm more than happy to answer them. Feel free to shoot me an email or respond in the course. Thanks.